Welcome to the second lecture of the telecom course. Some of you were not here yesterday, so you have the detailed syllabus in the e-learning platform, but just to recall a few things. If you qualify as an attending student, which means that you attend either 10 out of 12 sessions for the 3-credit course or 20 out of 24 sessions for the 6-credit course, you can take the exam with the attending student format, which means 50% of the grade will be on a group work, maximum 4 people discussing the emergence of a new telecom service, of a new company, or the evolution of an existing company, or any other issue which might be relevant for the course. If you're attending, and 50%, of course, it's a written exam at the end of the course. The written exam will be in January for 6-credit students, and in October, late October, for the 3-credit students. Okay, exchange students, I think, have a special exam in December sometimes. I think that now dates are available. I'll try to learn your names, okay? But while I'm doing that, if you please can come and tell me your name at the beginning or at the end of the lecture so that I can keep track, okay? And so that we can interact with each other. The first part of the course, as I was saying yesterday, has to do with the sector characteristics. So we are now analyzing technological evolution, and we will also analyze the role of different actors in the evolution, in particular of the fixed telecom networks for now. Then we'll move to the mobile networks. We'll then analyze the demand structure, so what different type of consumers demand, what are the characteristics of the consumer's needs in this particular environment, thinking of telecom services and of multimedia services. And we'll then move to the more business model type of analysis. We will take a more managerial approach and we'll investigate different business models and also different services that are emerging in the new multimedia, if you want, sector. Okay? This is where we stood yesterday. We discussed the role of the traditional telecom network, which was developed just for voice services, mostly for voice services, and we outlined the different characteristics of the network. In particular, we said that the way in which the network was developed was characterized by economies of scale, which means very high fixed costs, very low variable costs. Firms who develop the network are now trying to exploit that infrastructure to deliver different types of services, which means that voice is not the only service that these companies are trying to deliver, but also different types of data, video services, and more in general, integrated services. Okay, so the so-called multimedia services. And this is why we are saying that firms are trying to make money by exploiting economies of scope. Okay? The marginal cost of the call is still very, very small, which means that if we consider the two parts of the economies of scale, which is high fixed cost and small marginal cost, this will stay very small and very stable over time. If we think of the fixed cost, which means the cost of building the network, that is the part of the economies of scale that has changed dramatically over time, both because the cost of the traditional telecom network has changed and also because alternative networks have emerged in this sector. Okay? So you can now deliver voice services or data services through different type of networks. Not only the traditional circuit switch network, but packet switch network like the internet, for example, or cable TV or mobile networks or other type of infrastructure. Okay? The technological and economic characteristics of the sector made it a natural monopoly. Okay? And this is the reason why in the past 20 to 30 years, we just had one company in the sector providing voice, not only voice, also data services. Okay? So there was a technical reason for this, and that was the presence of very high fixed cost, which made it natural to have just one company. That company was heavily regulated, to a different extent in different countries. Okay? Regulated mostly in terms of the price that it was charging to other companies or to the consumers. Okay, so connection fees basically for other companies and the price of the calls of, or the price of other services for the consumers. Okay? Now, what happened next? There has been a series of drivers of changes in the market. Okay? And this dates back to mid-80s, beginning of the 90s, according to different types of changes. The first of which is the emergence of a new demand, new types of consumer need for more efficient handling of multimedia signals. Okay? Now, we'll go back to the idea of efficient handling. The basic issue that consumers were interested in was quality of service. Okay? So one thing is that if I have to make a telephone call over the network, one thing is if I have to watch a video, if I have to exchange data, files, whatever, over the same network. Okay? The requirements, even on the traditional network, change very much. Okay? And this put lots of pressure over the existing telecom operators on the one hand, but on the other hand, opened up new venues for businesses, for companies that were not the monopolists in the telecom industry. Okay? So the emergence of new types of needs, the emergence of new services, of the possibility of delivering new services over the network opened up competition. Okay? This was one of the most important drivers. The second driver, which is strictly related to this, which somehow generated changes in the way in which the network and the infrastructure was designed, was the desire to exploit more economies of scale and scope on the firm side. Okay? During all the course, we will always try to sort of linking the demand and the supply side. Okay? They've always gone together in this particular environment. Okay? Now even more. But the idea is that the structure of the industry as multimedia services started emerging in the market went from a very vertical and integrated sector towards an industry with lots of horizontal, if you want, separated functions. Okay? So what we observe now is that if a company is a network provider, it provides the network for several different services. Okay? If a company is a content provider, it provides the content over a type of different networks. Okay? So the idea is that I do not have anymore a telecom company, full stop, or an IT development company, full stop, or a TV provider. Okay? What I have is content providers, network providers, companies that specialize in a specific function and that make money because they are more specialized. Okay? We'll see when we will discuss the supply side of the market that in the traditional industry, especially in the US and in Europe, companies were really vertically integrated. Okay? So AT&T was completely integrated from the network provision to the content and service delivery. Okay? What is happening now is that these companies are not integrated anymore, and they try to specialize, because that's where you actually make money from. Okay? Finally, yes?
Sorry, I don't really get from vertically separated sectors to horizontally separated.
Yeah.
What you were just saying is with AT&T, for example, or I don't know, telecom, that they used to be vertically integrated.
Yeah.
And so now they disintegrated.
Yeah, basically the idea is that, let's take AT&T, okay? AT&T used to be a telecom operator, full stop, okay? It used to have a network developed over time, and it was providing a content, okay? Now, the content was a very simple type of content, voice and data to a certain extent. Okay? AT&T was not a specialized content provider. We could say that probably it was a specialized network provider, but in any case, it tried to vertically integrate it along the value chain of the telecom service provision. Okay? And the same if we take a broadcasting company, okay, the idea was that the type of service that the broadcasting company was providing went from the network provision down to the content provision. Okay? What is happening more and more now is that firms are trying to disintegrate it, or better, they are trying to specialize in one part of the network, which means that if I'm providing a telephone service, for example, if I'm just an intermediary, okay, chances are not very high that I can provide very value-added content, but I buy it from someone whose job is actually to develop the content. Okay? Of course, we have companies that are more integrated than others, but what we observe more and more in recent times are joint ventures, alliances, not very much vertical integration of companies. Okay? So you specialize in one of the function, and then you make a joint venture with someone else who's also specialized in another function. Okay? American Online, Time Warner, for example, joint ventures. A typical joint venture from two sides of the market, a content provider, okay, Time Warner, that's what they do, and a network, or if you want, an internet service provider, American Online. Two very big companies, not really vertically integrated, but trying to put together competencies in order to compete in the market. Okay? Still, we have the ex-monopolists, especially in some countries. I'm thinking of Japan, for example, which are heavily still now integrated. Okay? So they basically provide any kind of service through their network. Okay? But the tendency, especially in Europe and in the US, is to disintegrate, to specialize. Okay? That's where you make money. Okay? Third, well, this is just a list. It's not really meant to give order, but technical change, of course. All these processes were possible because of technical change. Okay? And we'll see what really happened in the telecom industry, but the idea is that changes took place both in the traditional network, okay, so upgrading of the existing networks, development of new access technologies, for example, ADSL, very basically speaking, and in the development of new infrastructures, brand new infrastructures. Okay? Now, the process of upgrading of the traditional network is very different from the process of development of new infrastructure. Okay? It is very different in terms of costs. So if we think back in terms of business model, okay, one thing is building a fiber optic network, one thing is upgrading the existing network, putting an IDSL technology on top of that. Okay? Costs are very different. Potential revenues are very different. ADSL does not have the same possibilities from a technical perspective as fiber optics. Okay? So whenever I choose one technological path, okay, I'm dismissing something else. I'm just saying, okay, I'm not interested in fiber optics. Okay? And these companies are now actually competing with each other. It wasn't the case, because the traditional telecom operators, infrastructure providers, were actually the ex-monopolists having the largest market share. Okay? And this was true for almost any country. Now, as soon as new networks opportunity came out, this meant that new companies were actually investing in the network without any legacy in terms of technical competencies, in terms of existing infrastructure. Okay? They just had to choose where to go, and most of them chose either fiber optics or mobile microwave technologies. Okay? Technical change went somehow together with an important issue at the public level, which is the public concern over the reliability of the network. Okay? Reliability means not only quality of service, it also means security of the networks. Okay? So as soon as packet switching technologies came about, for example, concerns for reliability increased very much. If I have a dedicated line between two people, and these people are exchanging data or information, okay, that line is quite reliable. Okay? It's dedicated to the conversation, which means to the transmission of information. I do not really have to worry too much about reliability. As soon as the network becomes open, which is basically what the internet architecture is, okay, as soon as I just throw packets of information over the network, then I have to worry about reliability. And that's a public concern, okay, besides being a private one. Because, of course, that's where most of the money, especially at the beginning, came from. Okay? So technical change and public concern went hand in hand at the very, very beginning. Okay? Plus, we had deregulation because we had new companies being allowed to compete in the market. Okay? So we had technical change that allowed a more efficient use of the network, but at the potential cost of reliability, first. Public concerns over this reliability, and the presence of different companies, which couldn't be regulated and controlled as they used to be. Okay? So as a government or as a state, if you want, I cannot have control on each operator in the market. When the industry was regulated, okay, I had a monopolist and this was bad, but at least the control was higher in a way, okay? Always a trade-off. Technical change, big driver for competition, and that's good from a social perspective, but reliability gets lower, okay? Both from a technical and also from a regulation, if you want, perspective, okay? And this is something that governments have started worrying about. And this is also why, for example, we've witnessed the development of all kinds of security enforcing technologies, like the encryption technologies, for example, came from here. Okay? With circuit switched networks, I didn't really need something very advanced to guarantee reliability. Okay? When the network becomes a packet switched network, well, I have to worry about reliability and quality of service as well, but reliability is something that governments are quite keen on controlling. Okay? So, demand, supply, if you want public concern, technical change. These were the main drivers of change in the market. Okay? Deregulation, just to give you a brief overview on something that I'm not focusing on, took place at very different stages in different countries. Okay? Starting from the US, then going to the UK, and then much later on to other places in Europe. Okay? Now, the different time horizon in which the regulation took place had important implications for the competition in different countries. Okay? And let aside the US, if we look at Europe, for example, or if we look at Japan, okay, what we observe are very different patterns of competition in very different environments. Okay? In the UK, you have the presence of cable TV operators getting into the telecom environment. This is something that hasn't happened, for example, in Italy. Okay? In Japan, still, you have one operator basically dealing with most of the infrastructure and of the services, in the fixed and in the mobile environment. Okay? So the timing of the regulation mattered very much for competition. Okay? Because also it went hand in hand with technical change. And if companies were not allowed to exploit technological opportunities, of course they missed a big possibility of making profits and revenues. Okay? And of course, as the companies and the structure of the sector becomes global, this becomes a very important issue. Okay? I'm not going in the detail of the regulation, but think that the US started regulating in 1984 with a split up of AT&T, and in Italy, okay, we had full deregulation starting more or less in 2002. It's almost 20 years later. Okay? The UK somehow in between, other European countries a bit later on, other countries in other parts of the world still later on. Okay? Now, yes?
Why are countries lagging behind in deregulation?
This,
of course, some of, I don't know, some African countries are, I mean, of course they have infrastructure problems anyway, but, I mean, what about some, I don't know, do you have an example?
do you want examples of countries that lag behind?
Yes, and it's kind of
France, Italy, Spain, okay? It's just political choices, let's put it like this, okay? It's basically the lobbies of the big telecom operators sort of hindering the process of deregulation, okay? When you have to deal with a monopolist, it's always a big issue. Now, in the US, they went for the very strong, somehow, way, which was let's split up AT&T, okay? And that's it. AT&T was, in a way, less powerful, also from a political point of view, than France Telecom, even Deutsche Telekom, Telecom Italia in Italy. Okay? These are the countries that should have respected the European Union, of course, laws about the regulation, but just took time. Okay? The second, this is the political explanation. Then there is another explanation, which has to do more with the companies that were actually ready to enter the market, okay, and the technological endowment of the companies. Now, I have in mind very much both France and Italy, okay, and there were not really many competitors ready to get into the market and develop a fully complete network for multimedia services. Okay, this was because also the existing monopolies. Okay, so no incentives basically to get into that market. Okay, the UK, was slightly different because the cable TV operators were already there. Okay, and so they were the, let's say, ultimate actors that could actually compete against British Telecom and all the others operators. In other countries, the situation was less clear from this point of view. But to me, the main problem was really a political issue. Political lobbies, let's put it like this. Yes?
I think the change will be introduction of telecom where even for the next even if the market is open up today.
Oh, yeah. But the market opened up much before the advent of Tele2, even in Italy. Okay? Tele2 was not actually the first entrant, let's say, after the incumbents. Okay, we had a series of new entrants, new is not the correct word, for example, Infostrada, to some extent even Tiscali, which was an internet service provider, somehow entered the market. Okay? The problem was that the market was really heavily controlled by the big monopolists. And the second issue was that most of these companies didn't have the access to the very last mile, which means that they could compete over the long-distance network. Now we'll get into this. Okay? But when it comes to actually providing the services to the house, okay, hello, providing the services to the house, not all the companies were ready to do that. I feel controlled. Okay? Which means that, in a way, the pattern of competition in different countries was really heavily dependent also on the technological infrastructure. Okay? The first real competitor to Telecom Italia in Italy was Fastweb, okay, in my opinion. That's a company who decided to build a completely different infrastructure. Okay? Say, okay, there's no way we can go on with the circuit switch network even if upgraded. Let's do something else. Let's do something different. They had money, because you need money to build, of course, fiber optic networks. Okay? And they exploited the increasing demand for multimedia services. But as far as voice service and data services are concerned, okay, really competition struggled very much in most countries. Okay? And that was a political issue and somehow also a technological issue. Okay? So not many companies invested heavily in the network infrastructure. They were somehow renting the network from the ex-monopolist, okay, with regulated fees, and they were allowed to provide the service. But in the end, you always had to go back to the monopolist, okay? The company was the one who had access to the local loop, let's say, to the very last mile, okay? And competition started increasing very much just when new infrastructures were developed in the market. And of course, we're talking about the fixed environment, but the very big competitor, and we'll come to that, is the mobile market. Okay? Again, a truly new infrastructure, something different. Okay? Now, in face of those drivers of changes, there were lots of limits in the traditional circuit switch network architecture. Okay? The first of which was that the so-called dedicated capacity of the network, you remember you just dedicate a line between two people, was not very good for handling data transmission. It was not very good from an economic point of view. It was a waste of space, in a way. Okay? And the idea was that to set up and then conclude the call, you needed very long time. Okay? The network was not efficient at all to deal with data services, not to talk about video services, but we're still, I mean, in the internet, pre-internet area, if you want, okay? So the first problem was that the type of network in place was designed for voice and had huge limitations when it came to data. Okay, you're probably too young, but I remember the very first emails that we were sending through Telnet, not even the IP protocol or whatever. Okay, it was really slow. I mean, the underlying infrastructure was really not handled for this. Second, and this is related. Now, people talk a lot about the digital revolution. Okay? And we could stay here for a long time discussing the advent, for example, of the digital TV, okay? Or the advent in general of the digital transmission. The idea was that as soon as data services became available, okay, and data, you remember yesterday, are basically bits, okay, the network was not really good to transmit those data. Okay? Because it worked as an analog transmission network, okay? Which means that you need a modem, in other words, to transmit digital signals, okay? And this means that the quality is just not very high, okay? This is what happened also to a different extent with the advent of digital TV, for example, okay, with a high definition. At the very beginning, the idea is that you need a modem just to convert the signals, which does not mean that you get very high quality signal, okay? You get a high quality signal that somehow needs to be converted in order to arrive to you, okay? That's the same thing, okay? So the network was limited in the sense that it was not really designed from a technical and from an economic perspective to handle this type of traffic, okay? And this had to do with the infrastructure. So, twisted pair of copper wires. This is what you get in 90% of consumers, at least, houses. Okay? This was constraining very much the transmission rate. Not only this, but remember yesterday we saw the different network topology. Okay? We were saying that the star topology might be efficient because you just have a switch, and then the switch is directing the information to different nodes, but of course if the switch collapses, the network fails, okay? So the way in which this network was designed implied a high vulnerability to single point failures, okay? Which is exactly the opposite to what happened, for example, in the IP network, okay? The way in which the internet protocol is structured means that even if a single point fails, the network does not collapse. Okay? This was not true for switch networks. Transmission rates, forget about that. Okay? Even with DSL technology, not ADSL, but just DSL technologies, the transmission rates were not very high. Okay? So voice is okay, data, okay, video, forget about it. Okay? So again, this was the network which really needed to be upgraded in order to meet the requirement of users for new multimedia type of services, which were emerging in the market. So again, going back to the deregulation issue, okay, having a very late deregulation meant also that lots of companies lost the opportunity of upgrading the network, developing new infrastructure, providing new services. Okay? Because they just didn't see the point in doing that. Okay? With one monopolist having 90% of market share, where can I make money? Okay? It was more convenient for that company to invest in new services. Okay? But from an incentive perspective, new companies didn't really have incentive for doing so. And those who did were companies that were already active in, let's say, close sectors to the telecom. Okay, so broadcasters, for example, cable TV operators and so on, they had a network in place. It was just a matter of trying to transmit other type of signals over that network. Okay? So the traditional network was extremely limited in terms of opportunity for delivering multimedia type of services. Okay? And that's why companies started investing, and this was, again, mid-80s, mid-90s, let's say, both in the long-distance part of the network and at the very local level. Okay? Now, without going into the details, the telecom infrastructure has two big parts. Okay? One is the so-called inter-office, but basically long-distance transport. Okay? Another thing is getting the service to your place, the local infrastructure. Okay? Most investments were done at this level. So actually, companies started investing heavily in order to upgrade the network over the long-distance transport, which is understandable in that this was also the network which was relevant, for example, for international communication. Okay? At the local loop, the upgrading and the technical change was much slower. Okay? And this meant also that companies were really dependent upon existing incumbents, operators. Okay? And if that operators were not changing, from a technical perspective, the infrastructure, new companies couldn't exploit the local networks. Okay? Consumers, in any case, needed to get back to the incumbent. Okay? In the long distance, something happened. Okay? So here is actually where most of the money of the investment concentrated. Okay? First of all, big change. Okay? Shift from analog to digital technology, which means that not only data, yesterday someone was saying, yeah, data are bits. Voice is a wave, video, different type of signals, okay? Now everything is digital, which means that even voice and video are basically, okay, can be codified as bits. Which means that both voice and video on the one hand and data on the other hand can be delivered over the same network, okay? It's all a matter of bits. So you're just coding the information in 101010, and whether it is a voice conversation or a video service or data transmission, it's the same thing. It's the same thing, but of course it requires different capacity at the network level. Okay, so we still need different bandwidth if we want to make a phone call or if we want to see a video. Okay, but in principle, the basic characteristics of this type of services are exactly the same. Okay, so you wouldn't recognize a voice conversation from an email simply looking at one line of code. Okay, these are bits. This happened first at a very long distance. Second, huge change. Okay, replacement of the networks. Copper wires, twisted pairs of copper wires were replaced, especially at the long distance, with fiber optics. Okay? We look at the development of the fiber optics all over the world. The first routes that were actually interested in fiber optics were the international ones. Okay? The US and UK in particular started investing heavily in this technology in order to have more efficient international communication. Okay? What? That was depending on the countries, but around the mid-90s, something like this. Okay. Again, it depends very much on where you look, because the U.S. have a particular story because AT&T split meant that lots of different companies could enter the market. Okay, and in particular network providers at this level. Okay. In Europe, for example, at least in Western Europe, deregulation was extremely low, and this means that not many companies could actually allow to invest in these technologies, because this technology is extremely expensive. Okay? So here what we observe is that the transmission lines, remember yesterday we were talking about the cost of the switch and the cost of the transmission line. Here transmission lines becomes extremely expensive. Okay? So then you really need to have lots of consumers using the network in order to recover your costs. Okay? You need a lot of traffic. This is the idea. Okay? It doesn't make sense to build fiber optics if you just have voice conversation between Milan and Rome. It just doesn't work. Okay? That's why they started doing this at the international level. Okay? To exchange data, to exchange information. This was right after the big internet diffusion. We'll come back to this. Okay? And somehow it was also driven by the needs of interchange across different data center, basically. Okay? The intelligent network, you've probably heard about the ISDN. Okay? You know what ISDN is? No idea? No one? No idea? Okay. When we talk about an intelligent network, we're talking about a network, okay, which manages the different calls or the different connection paths across different users in an intelligent way, okay, which means that you have switches that are automated, very often computer-based switches, okay, once you had people connecting people who wanted to talk to each other. Now you have intelligent switches that are trying to divert different calls and are choosing the routes of different calls so that calls do not clash. Okay? So basically you don't have congestion. The idea of the intelligent network is that you have switches that are so powerful that they're trying to choose the right path for each type of transmission, so for each type of conversation, which means, again, voice, data, whatever it is, so that you don't have congestion. Okay? The ISDN, which is, if you want, the network which was developed right before the old ADSL technologies, was still a circuit switch network. Okay? So the idea is that this was first developed at the very long distance transport level, and then it was sort of distributed over the local loop, okay? Mostly for business users. So you don't probably get an intelligent network, an ISDN network in your place, okay? But at the level of the business users, yes. Okay? This was a relevant issue, especially as soon as data communication diffused. Okay? With voice, it's not a big issue. You still have dedicated lines. But when it comes to data, you can throw lots of different information at the network at the same time. So either you have a very powerful routing system, which routes the different type of information in an intelligent way, or you have congestion and you just cannot communicate, basically. This is the idea, okay? So long-distance transport, the first part of the network, which was influenced by technical change, digital technologies, new infrastructure, and new network management, if you want, intelligent switches. Okay? What happened at the local loop level? What happened to your place, to your house? What kind of technology? How do you access the internet, for example, in your house? How many of you do have fast web? Or, okay, what about other kind of ADSL technologies? Half and half. Or some have both, probably. What about mobile access to the internet? Okay, Francesca, raise your hand. Okay, so we have just one person accessing the internet through mobile phones. Is that 2, 3, 4, 5? Not bad. So the whole investment in 3G technologies wasn't really actually corresponding to a big demand. But still, I mean, what happened at the local loop? Okay, so residential users, your house. Okay. Well, the local loop was a very problematic part of the network because, why was it problematic? Because it was not profitable. Okay? So from an economic perspective, think always as if you were an operator. Okay? You have to go through the old course thinking of operators. Okay? You do not make lots of money on consumers, by definition. Surely not on voice traffic. Okay? You know that the price of the telephone calls have really decreased very much. Okay? The local loop that goes into the house is not the profitable part of the network. Okay? So if you want really to make profits, you have to go somewhere else. You have to go long distance. Okay? If you look at the top 20 telecom operators, I'll show you next lecture slide on that. Okay? Most of them are active at the long distance segment of the market. Okay? But still, the local loop is important because it's where actually people get connected to the big telecom network. Okay? The conversion of the signals, for example, between analog and digital does not occur at your place. It occurs in central offices somewhere. You just get the signals, it gets converted, and then it gets transmitted to another user. Okay? The idea was that the voice signal was analog. Okay? So it was simply converted to a central office, a central switch, and then transmitted to another user. Okay? Much later then, at the long distance level, also at the local loop level, we had the emergence of integrated services digital network, the so-called ISDN. This caught the attention of lots of telecom operators. Okay? So if you read also engineering reports or technical articles back at the end of the 80s, beginning of the 90s, this seemed to be the way forward. Okay? This seemed to be the network of the future. It was still circuit switched. Okay? So it just had the intelligence, let's say, of routing different conversation over different transmission paths. But it was nothing more than a small upgrading of the existing network. And this was not by chance, because, of course, people who were investing here were the monopolists. Okay? So they had all the interest of pushing this type of technology. Okay? As opposed to, for example, the IP protocol, the Internet protocol. Okay? The packet switch technologies, because that required a completely different set of technological competencies, a completely different set of investments. Okay? This was just a matter of upgrading a little bit the existing network. Okay? And really, most of the operators went in this direction. Then the Internet came about. The IP protocol was developed, and we'll see in a moment how it came about. And telecom companies realized that this was not really an efficient way of handling multimedia type of services. What did they do? ADSL. Nothing more than an access technology, okay, so a bit that was added to the existing network. Okay? Again, think from an economic and from a managerial perspective. Okay? This was the less expensive upgrading, or the less expensive investment, if you want, that they could make. Okay? You have a network, you make it a little bit more intelligent, you add a technology, because this is an access technology. They didn't build any new infrastructure. Okay? You just add an access technology in order for users to be able to access different type of multimedia services. Okay? And that's it. Yes?
When was ADSL technically developed? Because, I mean, I'm wondering, why did they not jump the ISDN stage? I mean, was it a demand question, or was it technically not existing?
Demand had a role, because demand, of course, didn't really get immediately into the multimedia type of applications. Okay? Even when the Internet came about, before the number of hosts and users skyrocketed, okay, it took 10, 15 years. Okay? But at that time, people were already in need of exchanging data, for example. So the idea is that the ISDN was considered to be important in terms of managing the existing communications in a more intelligent way. Intelligent means also economically efficient way, okay, because that's pretty clear, right? And again, the big operators were pushing towards this, okay? Remember that we are here around the 90s, okay? US was regulated, UK started to be deregulated, other countries were still in the hand of the monopolists, okay? So the technological trajectory, if you want to call it like this, was just set by the monopolists. The agenda of the technical change, okay, was set by the monopolists, okay? Who, by the way, were part of the same standard committees. So even at the European level, or at the level of other countries, okay, these decisions were often taken in consortium across different operators. Okay? And they had all the interest of staying with a circuit switch type of network. Okay? The big alternative to this, actually, was the so-called ATM technology, okay? Which was a packet switch network. It was not exactly designed like the IP protocol, but it was something in that direction, okay? And that didn't work out, simply because the operators were just investing in upgrading the network, okay? It was an economic reason, nothing else, okay? It would be, well, if you think of it now, probably they would have been better just jumping here, okay? But they were not very forward-looking at the time, and they were making lots of money, okay? And again, since they're companies, they want to make profit. That's it. Demand was not so big at the time, especially at the local loop level, okay? And this means that probably even ADSL, DSL first and ADSL was not really needed, okay, for handling voice and data sort of random traffic, okay? And when actually multimedia needs came about, it was too late to convert completely to new technologies. Well, they could have invested in fiber optics, okay? But at that time, new companies were in the market, competition was higher, prices were lower, which means that profits were lower, and they were making less money, okay? So at that time, fiber optics was probably not an option anymore. And what remains to them was just investing in the, again, upgrading of the existing network, okay, providing ADSL. If you look at the history of different countries, what you observe is, again, that companies that managed to somehow steal market share from the incumbents are the fiber optic providers, okay, or the very broadband network providers, okay? Competition doesn't really come very much from the traditional circuit switch network providers, okay? It's the companies that did something completely different that succeeded in the market, okay? And what was left to the existing operator was just to upgrade to the new technologies that could actually route the different signals on different type of networks. This is what ADSL does, okay? It is not a big innovation. It's probably the best thing they could do, given the infrastructure that they had in place, okay? I'm not saying that this was a stupid approach or a sort of myopic strategy. Probably was the best, given the constraint that they had, okay? They could have done better before the IDSN, okay? Once everything was in place, then they just had to follow the path, okay? If you want path dependency, would be called somewhere else. But the idea is this one, okay? I have a technological legacy, and I cannot just get rid of that in the name of let's build broadband networks, okay? Probably now they are regretting, but regulation is still a bit loose in some countries, so they still make lots of money. And then you have all the developing countries issues, okay? So if I have to build a new network, probably the best thing is that I try to get into new markets, okay? And then you have the mobile environment, but then we'll get to that later on. Now, undoubtedly, the big change in the history of the telecom, the fixed telecom at least network, was the advent of the internet, okay? The internet changed not only the technology to transmit voice and data signals, but changed the structure of the industry, and it changed demand needs, okay? This was really the big change. So what we've seen so far are, if you want, incremental changes that happened in the telecom environment because of different drivers, okay? This was the big change, and this didn't happen in the telecom industry, okay? So it is very interesting from a firm perspective, looking at the history of the internet, because this is something that happened outside the telecom sector. Then, due to convergence and due to the digitalization of the information, the two converged and basically were merged, okay? But this had to do with computing, This had to do with the IT part of the ICT sector, okay? Telecom companies were not at all involved in the development of the internet, okay? Because really, if you want, the mindset of telecom companies was completely different, okay? They were thinking of voice. In the computing, people were thinking of data, okay? And it's like two very different communities that do not talk very much to each other, still now, okay? Different mindset, different interests, different fundings probably, okay? Telecom companies, remember, under the regulation, had also sort of they had to provide the universal service to everyone, okay? So they didn't just have the right to be monopolies, but they also had to guarantee that all the people got the service, the universal service obligation, so-called, okay? In the computing, people were just doing what they wanted to do, were just experimenting new frontiers, okay? The internet, I will show you some statistics in a moment. The internet increased substantially in terms of number of users, in terms of hosts, let's say from the mid-90s, even a bit later on, okay? First experiments date back to the first half of 1960s, okay? And basically, they are due to Baran from the US and Davis. Baran was working at Rand Corporation, which was a very big IT company, and they invented the packet switching technology, okay? So basically, they invented the so-called dynamic allocation of bandwidth, okay? Here are the men. This is Baran, and this is Davis. This was a very big change, okay? So no more dedicated lines, just distributed network. Remember that yesterday we saw the two possible alternative configurations, so the so-called mesh topology and the star topology, okay? There is a third possible way, which was not really contemplated by the telecom people, okay? Which was the idea of distributed network, okay? So the idea was that each node would have several possible paths to send around data, okay? What is the interesting thing about the distributed network? Okay, so these are the two possible alternatives that we saw yesterday. This is the distributed network. The intelligent part of the distributed network is that if a node collapses, not all the network does. Okay? So the idea is that the network is very efficient and is also very reliable in terms of securing the transmission of information. Okay? So distributed network, in any case, you have a path available between 2 points, even if some parts of the networks break down. Okay? The traditional telecom network was really dependent upon single points. Okay? So the internet actually, well, the distributed network in the first place on which the internet is based, really increases reliability. And this is something that the public sector liked very much. Okay? So you know that the internet was partly developed through public funding. Okay? This is a way in which they were trying to somehow secure the transmission of information. ARPANET. Okay? This was the big project behind the internet. Packet switching technology became actually the focus of the project. The idea is that the internet was born within the Department of Defense of the United States. This is not really correct because the internet was actually born more in the computing science department of the academia in the US. Then, of course, the Department of the Defense had a stake on that, they had interest in the network, and so they put a lot of money. Okay? But the sheer interest in this type of change came from the engineers, came from the computing people, okay? Not from the Department of the Defense. Okay? TCP/IP, we are still in the 70s. Yes, sorry.
You were talking about ARPANET.
Yeah?
It was in America, it was a state
It was that's a state agency, okay? It's a state agency, ARPA, okay? It was an agency, okay, let's go back. ARPA was an agency that belonged to the Department of the Defense, okay? And the ARPANET project was developed because the Department of Defense thought that the idea of having timeshare computing and distributed network was a clever idea in terms of transmission. So they had a stake in that, okay? They created the Advanced Research Project Agency in order to develop the network, okay? But it was not the locus, if you want, of ideas development, okay? That was very much a sort of individual interest development. TCP/IP protocol were developed immediately afterwards. And the very interesting thing here is that at that point, AT&T was the big player in the US, and then, of course, it had a big stake in the world as well. Okay. The Department of Defense asked AT&T to take over the management of the ARPANET, and AT&T refused. Okay, because it didn't see the potential of the network. Okay? Now you might smile now, but at the time, okay, this is what happened. So the biggest operator, the one that could have had really the control of the internet, well, it was ARPANET at the time, but then it became internet, okay, just refused. They just said, no, we don't want this, also because, of course, they were asked to manage that as a public service. Okay, and you know that, again, if you're publicly regulated, you do not make much money, you're still heavily controlled by the state, in the US in particular, and so they didn't just see the point. Okay, they were just saying, okay, you can take it, just leave it into the ARPA. Okay, you can just do the data transmission, packet switching, and fine with my networks. Okay, this was also before the split. So before AT&T was then splitted. Okay? In the early 90s, so much later than AT&T was offered sort of the control of the internet, we had the privatization, the development of the World Wide Web by Berners-Lee. I'm just sort of sketching the history of the internet, okay? You know where he was working? In Geneva, not in the US, okay? At the CERN, in Geneva, in Switzerland. He was just developing the World Wide Web, which basically was conceived as the collection of interconnected documents and other resources. If you go and look on the internet, you can find a sketch of the World Wide Web in Berners-Lee, which is this guy here, okay, mind. So, ARPANET, well, first experiments in the computing science department. The ARPA gets interested in that, developed the ARPANET and the TCP/IP protocol. AT&T refuses, big event. And then in the early 90s, the big network gets privatized, okay? And we all know the development of the browser by Mosaic Communication, which later on changed its name into Netscape, development of Java, and all the other developments took place. Yeah?
I'm just curious from the practical point of view, ARPANET, what did it give to, like, what was the practical thing that
the practical, okay, let's say, the basic idea of the internet and ARPANET in the first place was to connect different computers, okay, across different departments in the Department of Defense and in the universities. Okay? So the idea was really to have a system of data transmission, because that's what was they were exchanging, that was reliable, that was distributed, okay, so that it had nothing to do with the traditional circuit switch. Okay? So this was the basic idea. Very simple, if you think. The advent of the World Wide Web and then of other browsers and other sort of languages and applications is surely what made the internet jump in terms of diffusion, in terms of a number of hosts, in terms of infrastructure. Okay? It was not really foreseen So the idea was, let's create a powerful network for data communication across departments, full stop, university and public departments. Okay? This changed everything. Okay? So this was really what changed the aim, if you want, of the Internet. That's how the Internet became what we know is today. Okay? But the objective was very simple. Data communication, and that's why IT people were interested, not voice, not multimedia, was not at all foreseen. The infrastructure was not in place for that. Okay? Packet switching, which was perfect to manage data, because data communication, as we were saying yesterday, is very bursty, so it doesn't need a continuous dedicated line. Okay? And that's it. And soon they started seeing the potential of that. Not even AT&T saw it. Okay? And they were smart people. Okay? Yes?
But they were still diffusing the network through circuit switched lines, right?
But they were...
The telephone landline was the main driver of the...
In terms of... okay. In terms of underlying networks, okay, they were upgrading the existing lines in order to have the packet switching technologies working on that. Remember that it was not diffused worldwide, not even US-wide, okay? It was something really in the hand of a few departments, and so they were building dedicated networks for that. When the Internet started diffusing, then the problem that you are raising became important. Okay, so still we have the infrastructure, which is a circuit switch infrastructure. We can have the intelligent network, which helps dealing with data communication over packet switching network, but we have to invest somehow in something new, okay, in new transmission technologies, new transmission protocol. The TCP/IP protocol helped somehow overcoming this, okay, but still, I mean, if you access... Absolutely. You're using that. Yeah. Absolutely. You're using a twisted pair of copper wires with an ADSL modem or however we want to call it. Okay, and that's it. It's very different if we think of fiber optics. But again, we're looking at it now, okay, and now this big invention changed everything. But if you think of the data communication across computing departments, okay, probably you didn't really need big infrastructure. Again, it's always a matter of supply and demand coming together. Okay? So surely now if you access the Internet through a twisted pair of copper wires, probably without ADSL or through fiber optics, the result is very different.
Coming back to the security issue.
Yeah.
Then the security issue still remains the same. I mean, you need to protect your circuit switched networks, right, from any damage. Because if you cut those, then they destroy the clouds that are created, clouds of networks, right?
Yes. Yeah, okay, there are two types of security issues. One is the one that you're raising, okay, so at the level of infrastructure, let's say, okay? And still, if you're running the Internet over a circuit switch network, it doesn't really work very much. The second issue of security has to do with the communication itself, which means that if you're throwing lots of packets of data over a network, then you have to have an intelligent switch that somehow recombines the packets and delivers the right information. Okay? Not an easy task. And that's also why later on all the technical development concentrated on the switching part of the network. Okay? So the idea is, okay, I have the infrastructure, now I need to find someone or something that tries to route the different type of information in an intelligent way. Okay? Other question on this? Here we are. Host count up to January, well, February 2009, the latest figure that I could find, 94. Okay? This is the, let's say, most common use measure of Internet infrastructure, if you want, development. Okay? 94, 2009. This is 2000. This is when the number of Internet domain survey hosts started to increase. How many? Yes?
I'm wondering, so what does this exactly mean? I'm not familiar with the technical term host.
Oh, we are too, so. Okay. The host is basically Okay, it's the unit, if you want, of internet infrastructure that you can count. If you're talking about the telephone network, okay, you have the lines. So, no, it's not the end user. Okay, no, this is infrastructure. This is from a purely technical point of view. Okay, it's the way in which you can count the diffusion of. You don't have internet lines, but the idea is that you have the hosts that can be considered as the basic piece of infrastructure. Okay, this is a different thing. This is the word internet penetration rate. 73.9. We're talking always June 30th, 2009. Okay, 74 in the US, 60% Australia, 50% Europe, which is not a big thing. 30% Latin America and Caribbean, Middle East, Asia, Africa, and the average. Okay, are you surprised? Probably not. A bit more interesting than this is this statistics. Okay, so these are taking the word internet users a total. How do they spread across different regions? Asia, which does not have a big penetration rate of the internet in total, but of course, if we are taking the number of internet users, then it makes a big chunk. Europe, North America, and then all the rest. Okay? So the first statistic was just looking at different regions, what is the penetration of the internet in that regions. This is given 100, the number of internet users in the world. Okay, where can we find them most commonly? Okay, again, June 2009, so kind of very late statistics. Main features of the internet. So why the internet is so powerful? Why the internet has become really the most important network in the fixed environment, at least, for data and voice communication as well. Okay? Just a couple of things, not from a technical perspective. Again, I'm not interested in the engineering details. I'm interested in the economic implication of this. Okay? The IP protocol development. Okay, the so-called IP suite, which is basically the combination of packet switching and multiplexing. Okay? Modularity. This is a crucial feature of the internet. At the beginning of the lecture, I was discussing about vertical integration. Okay? Modularity allows company to get specialized on one particular bit of the network. Okay? This is something that helps actually competition in a way. The traditional telecom network was just ideally thought for one company, okay, to get hold of all the network. Modularity means that you have very different layers in the network. Any company, well, almost any company can get in any different layer. Okay? And this means that if you're looking at the basic infrastructure layer or you're looking at the application level, you find very different actors. Okay? And one question that you might wonder yourself is, where is it convenient to invest? Okay? If you had to choose developing an application or infrastructure, where would you invest? Who said application? Okay, do you all agree? Yes. You would invest in application, not in network. You?
Yes.
No, I was talking to her. She was nodding.
It's not perfect goal. Because there is network.
Okay.
Network, voice, then you only don't make money.
Okay. Well, it depends very much on what you run over the network. Okay? Because if you manage to get, for example, alliances with people who have very heavy content, then your network might become very profitable. Okay? Applications are good, but the problem with applications is that you're not always sure that you get demand for that. Okay? having layers means that different companies are trying to get, well, have tried to get into different type of the networks. Okay? The network layer, the IP packet layer, and the transport layer. Okay? Basically, the way in which the internet is structured allows for more competition in the sector. Okay? In the same environment in which we used to have just one company. Okay? Again, remember that this was not developed with the idea of allowing voice conversation. Okay? It was thought as an alternative network to do something different. Okay? Now, what it turns out is that companies that were providing telecom services can actually get into also the internet environment. Okay? And they can invest heavily in this particular technology in order to provide different services. Okay? And then, of course, you have the application layer. Tons of different applications and services. We'll see some of them during the course. Okay? Voice over IP, all the user-generated content application, for example. Everything is made possible because of the internet. Okay? As a user, you couldn't develop anything in the traditional structure of the industry. Okay? With the internet, you can make money as a user. Yesterday, there was a guy saying that he was starting up a company. Okay? You could do it yourself. It's not difficult. Okay? Think of Google. Okay? Think of any other kind of company. Okay? It wouldn't have been possible without this structure. And this is, I think, what is the most important reason for sort of getting the internet into perspective. Okay? It's interesting from a technical point of view. It's interesting because it changed the environment. But the most important thing is that it increased competition massively. Okay? Carlo, shut up. Okay? So what we will try to understand is who's benefiting from this structure. Okay? Are these the traditional monopolists? Or maybe new companies? Or Google type of companies? Okay? From an economic perspective, the internet lowered the costs. So basically, this type of network decreased substantially the costs for the operators. Okay? And if you think in terms of economies of scale, this means that the internet also reduced the need for having monopolists. Okay? And it's not by chance that deregulation came about more or less at the same time when the internet started getting diffused in the network. Okay? Packet switching meant that economies of scale were not anymore a big issue in the telecom environment. Okay? You just could have the same price structure even with few companies, with more than one company. Okay? And the idea that the packet switch network allowed an efficient use of the network means also that the prices could go down. Okay? Now, one of the big problems at the beginning of the internet development was the pricing structure. Okay? Who's paying for the access? Okay? Now, you pay your own connection at home. And why then I should invest as a company if no one is paying me? Who should pay? I'm just provoking you, okay? Okay, so what would be your business model related to the internet?
I have an internet company. I offer people free internet instead linking them to a pool of other companies that provide content.
Okay, and you're making money.
Companies will pay for me because I have users. My users get in touch with those companies.
Okay, and you make money basically doing an intermediary function between the users and the company. Do you all agree? If you had to run the internet, what would your business model be? Yeah.
The thing is, you can't build a wall around the consumers in the internet if you give them access to the internet.
What I'm saying, I mean, we don't put the wall. I mean, we some way like Google to select them and you offer them first to the consumers. Having this possibility to be offered as first, I mean, is a good possibility. Obviously, you cannot restrict them from finding somebody else, but you can switch those costs on their side. And why should users pay for that when their company is interested to get to the users?
Can I jump into the debate? Now,
so I don't think we're paying less. This is the thing. I don't think the cost for the consumer is increased. I'm paying for.
Oh no, it's actually increased.
Cost for internet. Then I have to pay, for example, for Skype or another communicator. So what's up? I'm paying probably exactly the same as I used to pay.
I would guess more.
Or even more.
Okay. Well, at the very beginning, the business model of the internet service providers were more or less what you are suggesting. Okay, so let's give away the access for free. Okay, and we'll see, since the internet is very successful, where can we make money on application, on advertising, although at that time was not a big thing. Okay, lots of them failed. Okay, so at some point they realized that the pure internet service provider model of free internet access was not good at all. Okay, at the probably you do not remember because you're too young, but at the very beginning, lots of internet service providers entered the market saying, okay, I'm giving you free access to the internet. Of course, the content was not as developed as it is now. And this somehow put some questions on, probably your business model is not wrong, okay? But still, I mean, they failed massively.
Now,
yeah.
If we think about the public importance of internet, right? I consider internet providers as a primary industry within the services industry.
Yeah.
Which should be also probably subsidized by the government in some way. I mean, it's such an important thing. Why doesn't the government provide some money, some cash for development of internet networks? Like in the center, for example, in New York, in Central Park, you have free Wi-Fi.
Yeah, okay.
It has become a public good, right? You have companies that are maintaining the Wi-Fi network, receiving money from the government.
Mm-hmm.
I'm paying taxes, so through taxes, I'm ready to pay for the Wi-Fi.
Yeah. I'm not entirely sure that the Wi-Fi could be considered pure public good. Okay, but still, I mean, I see the point of saying, okay, this is important, this has to be accessed by everyone, and then if people want to pay for specific contents, for example, then they pay for what they want, and not for all the rubbish that you get when you log into the internet, because this is another issue. Now, the policy at the beginning was exactly the opposite. Okay, so the internet was public, it then was privatized at some point. Okay, so basically they opened up competition among different providers, among which we also have the ex-monopolists. Okay, so they have a big stake on that. And then they started thinking of, for example, closing down bits and pieces of the internet. Okay, they were saying, well, I mean, why I need to access all this information? You have problems of information overload. It just becomes basically without control. Okay, so we could build sort of a private network, but then we get into what he was saying. That, I mean, the good thing about the internet is that it's an open public space in which different users can contribute, let's say, to its development. Okay? Now, if we try to close down bits and pieces of the network to build walls, then the nature of the internet changes very much. Okay? The reason why we're paying for internet access, both as private and as public, because even Bocconi University, of course, is paying, is precisely because just providing the access, okay, is not per se the guarantee that you can make money on the content that users are exploiting over the internet, okay? And internet service providers traditionally have been less powerful in terms of market shares than content providers, okay? So when Time Warner and American Online merged, okay, it was mostly in the interest of American Online. Time Warner had its own business, and it worked very well. Okay, they were an entertainment company. They were making lots of money. American Online started realizing that giving away access for free was not really profitable business. So they had to find a way to make money on users. Okay? Otherwise, of course, they would have run out of business. Then people started, internet service providers started to make money with advertisement. Okay? But still, I mean, it's not a reason for just giving away internet for free. It used to be like this. Okay? It's going back to pricing issues. At some point, they were suggesting, well, we price people according to how much they download for the internet. Okay? So not according to the time, but according just to the, if you want, load that they have. But it just didn't work. Okay?
This is very interesting because if you push this pressure from consumers inside the chain, and if you make those guys decide between themselves how they're going to make profits,
Yeah?
then you're going to raise the question of copyrights.
Yeah.
The question of copyrights. And you would have the question of copyrights solved, maybe.
I'm happy that you're very optimistic about it. I'm a bit less optimistic about these issues, being easily solved.
It has to be solved in one way or in another way. What I'm expecting is, again, the decrease of the prices for renting a movie, and increase of information, which is, in the end, good for us. So.
Yeah, man. I'm not saying that it's not good for me to have internet for free. Yeah. If competition was very high, I would agree with you. My point is that the competition is not as high as this structure would need. Okay? Which means that in any case, if you have an oligopoly of companies that more or less are managing the internet access for different type of users across different countries, then of course you have country specificities, but more or less it's the same all over the world. Chances that consumers can actually jump into the competition and decide the prices are not very high. But we will go back to this when we are, we'll analyze the services. Just to finish very quickly, okay, efficient use means that you can have bandwidth on demand, and this, again, going back to the pricing structure, was one of the ways in which companies thought about pricing the internet. Okay? Somehow users can now choose the quality of the applications. Okay? So if someone is very interested in video application, for example, the network that they use is completely different for someone who's interested just in voice or low quality data and video application. Okay? And in principle, it allows to exploit economies of scale and scope. This was one of the big drivers of change. Okay? So we started from saying firms need to find a way to exploit the network that is in place. Okay? Multimedia services. This is something that came out together with the internet. It had some relation with that. It is not just about the internet, and we'll see what happens in other parts of the industry. But still, this is a very powerful means of exploiting economies of scale and scope. Okay? And the idea is that you can use the same network, providing that you upgrade it, to deliver a series of very different services. Okay? At that point, you might be able to give away the internet access for free. But you have to be sure that you make money on this, okay? And this is something that companies are not really seeing as an immediate source of profits, okay? Okay, we stop here. Next week we look at alternative networks, and then we get more into the structure of the industry.